Renewable Energy Using Microbial Fuel Cells by Arnav Doshi from Sullivan Elementary. Abstract. There are many renewable sources to generate electricity. Since I wanted to learn about biomass energy, I chose to experiment with microbial fuel cells. Question and hypothesis. I'm trying to experiment if MFCs can generate more millivolts as more time passes, because the bacteria multiply as time passes by. Research. A microbial fuel cell, or MFC, is a device that converts chemical energy to electrical energy using the catalytic reaction of microorganisms. So over here, there will be the bacteria Shionella or Geobacter, and then one of them will feed on the soil and nutrients, like the sugar and nutrients, and then they will produce ATP with electrons as a byproduct. Those electrons will be attracted to the anode and will be transferred through the wire, through the blinker board, and through the other wire to the cathode, completing the circuit and lighting the bulb. Basic facts. Some basic facts of MFCs are that MFCs can continuously produce electricity. Shionella can be found almost everywhere on Earth. They release electrons and transfer them to their neighbors via conductive appendages. Geobacter live deep underground. They can breathe iron compounds, munch up pollutants, and clean up the environment while getting rid of electrons along the way. Advantages and disadvantages of MFCs. There are pros and cons of MFCs. It can derive energy from soil and waste, even from the mud in your backyard. It saves energy to treat waste and has low emissions of carbon dioxide. There are also some cons though. It can only produce limited power, and a mediator may have to be used, which is a substance that increases electron transfer between bacteria. These chemicals cost a lot of money. Materials. Here's the list of materials I use to make an MFC. Procedure. How to make an MFC. Take a container, put some mud, make sure that there are no air bubbles or light bulbs in the mud, then put an anode which is connected to a wire, then put more mud, then place the cathode which is also connected to the wire. Close the lid with wires from the cathode and anode coming out from the container's lid. Ta-da! Your MFC is ready. Now just connect the wires using the blinker board and the LED will light up. This is how the finished MFC will look like. These are the readings from the MFC I made. You can see that the millivolts generated increased daily. CERR. Based on the experiment, I can claim that MFCs generate more volts as time passes by, which was evident from the readings. This happens because bacteria multiply continuously, and therefore more electrons are released, generating more volts. Here's the bibliography for this experiment, and thank you.